Welcome to Easy Algebra. What we're going to look at today is word problems and modeling. So, almost all word problems are a form of modeling. Modeling is taking a real-world scenario and representing it in a mathematical expression or a mathematical equation. And modeling can be exact or it can be statistical. So in exact modeling, you have something that always behaves exactly according to an equation. But there are also things that behave approximately according to an equation. We're going to focus mostly on word problems that are precise. So we're going to look at these. When you have a word problem, we need to talk strategy. How do you solve it? You should always start by reading the problem at least twice. The first time you read it, look for things that are general. What is it asking you for? What do you know? The second time, read it carefully. Look for special keywords and other things like that. Once we've read our problem, we want to model it using some sort of visual. So visualize the problem. This will ensure that you understand what's at play. So if the problem involves geometry, any form of shapes, or anything that could be modeled using geometry, draw a picture. Label any variables before starting. When you're working with a problem that involves like x and y, tell me what x is before you begin. So I'll just start this with a statement. Let x be, and then whatever x should be. You know, so let's say you're working with a problem that has coins. Let x be the number of quarters. This ensures that when we come back later, we know what x represents. We won't get confused about which one is x and which is y. So let's look at some word problems and how we can model them. So here we have a rectangle. A rectangle has a length that is 3 more than twice its width. If the area is 54 square units, find the length and width of the rectangle. So here, just with this broad overview, I know we have something that's geometrical. We can draw a picture. Furthermore, I know that we have the area, so multiplication will be involved in some way. I'm going to read it again, looking for those key elements. So a rectangle has a length that is 3 more than twice its width. There's a relationship here between length and width. So when I think about my picture, I have a rectangle, and they've told me that the width, we don't know. We could call that W, or we could call it X, just because I think most of us are more comfortable with that. The length is 3 more than twice its width. Twice the width is 2 times X, and we need 3 more, so 2X plus 3. Alright, so we've taken that first sentence. A rectangle has a length that is 3 more than twice its width, and we've turned that into a picture. The area is 54 square units. Find the length and width of the rectangle. So we know that the area of a rectangle is always equal to length times width. Here, our length is 2x plus 3, and our width is w. Our area is 54, so we can plug that in. 54 will equal 2x plus 3 times x. Our length became 2x plus 3 from here. Our width became just x, which is what we said the width would be. Now we can solve for x. So we take this equation. 54 is equal to 2x squared plus 3x. We could move the 54 to the right side using subtraction. So 0 is equal to 2x squared plus 3x minus 54. So now we can solve this by any method that we choose. Since 54 is a large number, it might be most convenient to select the quadratic formula, where x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So now x will be equal to negative 3 plus or minus the square root of 9 plus negative 4 times negative 54 will become a positive, and then 4 times 2 is 8, 8 times 54 is 432, all over 4. Simplifying what's under our square root, we get 441. So now we go to our perfect square roots. We know that 21 squared is 441. So this would become x is equal to negative 3 plus or minus 21 over 4. So at this point, then we now need to separate it into two separate parts. We have the positive, x is equal to negative 3 plus 21 over 4, and we have the negative, x is equal to negative 3 minus 21 over 4. By adding in the numerators, we can then simplify. And we find that our possible answers are 4.5 units or negative 6 units. Here we need to stop and make an interpretation. X is a width, and we know that, so we mark that right here. Let x be the width of our rectangle. Since width is length, it cannot be negative. So we're going to reject this. Distance is never negative. So our answer must be 4.5. So then we come up and we check that. Will that work out? So we need to check what 4.5 times 2 times 4.5 plus 3 would give us. It would be easier to keep this as an improper fraction, which we already know is 9 over 2. So now we can cancel the 2 with the 2 in the denominator. Rewrite as 9 halves times 9 plus 3. It's going to become 9 halves times 12. We can again cancel. 2 and 12 cancel to give us 6, and 9 times 6 is 54. That should be the area, and it does match the area we were given. So now we've found our width, but we also need to find the length. So to find the length, we come back up to here, 2x plus 3. So we 2 times 9 halves plus 3. These again cancel. We get 9 plus 3, or 12. So to answer our question in the final form, the width is 4.5 units, and the length is 12 units. So it's important here to notice a couple of things. Finding x did not answer our question. X was the width of our rectangle, and we needed length and width. So we had to give two answers. So if we had solved for x and just given this answer here, that would not have been enough. We had to make some interpretations along the way. We rejected this answer because it didn't answer the question about a distance. We had to know our quadratic formula, or you might have been able to solve this. I believe you could do it by factoring as well, if you felt comfortable with that. And we always go back and check. So here we knew the area had to be 54, so we multiplied our length and our width. 12 times 9/2 is 54. So now we're going to look at a similar problem, but this one we won't be able to draw a picture the same way as before. So here, a car rental company charges $40 per day, plus 25 cents per mile driven. If your budget is $150, how many miles can you drive in one day? So let's look at what we were told here. We know that we are looking for the number of miles that you can drive. How many miles can you drive in one day? We know the cost per day and the cost per mile. The cost per day is going to increase consistently times the number of days, and the cost per mile will increase per the number of miles. We know the number of days, so one day, how much will I pay? It's going to be $40 plus the number of miles. So here we're going to set up a linear equation. The amount changing is the 25 cents per mile. This gives us a slope. The $40 per day, since we're only gone one day, is giving us our y-intercept. So we can use the form y equals mx plus b. So here, y is going to equal 25 cents times x plus 40. But we need to define x again. So let x be miles driven. Let y be the total cost. So they told us that our total cost or our budget is 150. So the maximum number of miles that we could drive would be if we spent all of our money. We simply plug in 150 for y, and we solve the resulting equation. Now here, when we divide by decimal, it's the same if you move the decimal place back in both the divisor and dividend, you'll get the same result. So this would give us the same. 25 fits into 110 four times, which is 100. That gives us 10. It'll fit in four times here, which will give us 440. So 440 is equal to x. X was the number of miles driven in a single day, which is what we were asked for. So we can answer the question 440 miles.